Vroom vroom! Oh god, do not drink a potion of speed and run on a road.
Oh no.
I ran about 400 blocks in 2 seconds.
Wow.
I then exploded because my hunger ran out. So apparently running at Mach 12 makes you really hungry.
I imagine it would.
Ooh, I wonder if I can make the magic boots that make you run faster and go even faster. I wonder if they stack.
What do you think?
Probably not.
They might actually stack.
I don't know, it depends on how all the mod makers coded their stuff. I can fly into the forever!
Forever?
I can fly in the forever, yeah.
Oh, wow.
I'm actually wondering if someday if we can actually break the light barrier.
We may never break the light barrier per se, but we'll certainly go faster than light one day.
Wait, that's the same thing.
No. Physically going faster than light is not the same as breaking the speed of light. Physically going faster than light may be impossible, but going faster than the speed of light may be possible.
How does that
That is, if you set a straight line and you use your method of going faster than light, and light just travels through normal space, light will be physically moving faster than you. However, you'll be able to traverse space faster than light.
What? You
Wormholes,
have to
warp
explain.
speed.
It sounds.
Think of it like
sounds
this.
funky, but
Think of it like this, Huvi. You have a laser pointer pointed at your destination, and then there's you traveling your destination. You versus light, you will never travel at the same speed of light or faster than that, you physically. However, there may be methods in the future where we'll be able to travel faster than the speed of light, but we ourselves will not be traveling faster than the speed of light.
So, like, teleportation?
Teleportation, teleportation, I'm trying to think. Warp speed, that sort of thing. Wormholes.
Warp speed is moving faster than the speed of light, though.
Warp speed is not moving faster, but warp speed is moving space faster than the speed of light.
but not moving faster than the
stand
speed
still.
of light.
Oh! Okay, I forgot. Warp speed is the stupid, you stand still, everything moves around you.
Yes.
Makes no sense whatsoever
Kind of.
in my head.
No, warp speed is space. You physically warp space so that your piece of space moves faster than the speed of light, but space can expand faster than light. We've seen it or at least we've deduced it through the Big Bang. But you stand still you are still moving slower than the speed of light relative to light. Or you can fold space too. That's an idea where you actually physically fold the universe in half.
So two points are right next to each other.
I like the concept of I'm just moving faster than the speed of light because it's simpler in my head.
It's not that hard of a concept, Oof.
Also,
I
congrats,
know,
Jason.
but
Yeah, all I needed was that one level, and it was fucking cake.
also I have fantasies of being the Flash and like creating tornadoes by running around people. So if I could run faster than the speed of light, I could achieve those fantasies.
Though it is interesting, if you keep adding like nines or zeros to going as close as possible to the speed of light, just how much energy you're adding up.
Oh yeah.
Like if you add like 10 nines to this, you still not going the speed of light, but you've accumulated a shit ton more energy to doing that.
Oh,
Stephen got it. Stephen understood it.
if you could run just below the speed of light, like within tens of miles an hour of it,
So instead of C, you'd be traveling at 0.9 C?
something like that, yeah.
Okay. Okay, if you could do that.
If you could do that, if you hit something, would you immediately incinerate, or would your speed allow you to not explode on impact?
Theory suggests a couple of things could happen. You could have normal interaction, which would be everything splat, just really happens really fast. But there's other theories which state that, which suggest that some strange quantum effects take effect, and you may, depending on the material, pass through it.
Or you might just fuse with the matter.
That's also very possible.
It's also possible, yeah.
And I'm not going to get the crowbar to try to pry you out from the metal
Philadelphia
from the
experiment, man. That's all I
metal
gotta
ship
say.
you've been in.
And the reason I asked this is because I got into an argument with a coworker Friday about, we can't. a lot of the things we see in like sci-fi movies can't be possible because our laws of physics don't allow it. And I brought up just a simple argument of, well, when we get very, very small, our laws of physics fall apart.
Yes.
So what happens when we get really, really big or really, really fast?
Well,
Do
then
they also hold true?
Well, we have those though. We already have those because we have special and general relativity for the really, really big.
Well, okay, yeah, but we also have that for the really, really small, correct?
No, that's called quantum physics, which behaves significantly differently from special and general relativity.
You're just trying to burst my bubble, aren't you?
No, I'm telling you that atoms do not behave with gravity the way people expect them to behave with gravity, and it opens up a whole host of serious fucking conundrums. That's why the theory of quantum gravity is needed, but no one can figure it out yet.
They are working on it, though.
Yes, it's being worked on.
The thing is, it makes more sense when I'm drunk than sober when I try to discuss it. I don't know why. It's just that the whole matter of the universe just makes a whole lot of more sense when I'm drunk.
Because you give less shits.
The universe makes absolutely no sense to me when I think about it. I mean,
Yeah.
I can sit there and I can postulate and I can say, oh yeah, we're doing this, that, and the other thing, and it's really this and that. But then you break it down to quantum level, and you're like, well, why doesn't an atom get directly affected by
Anything.
gravity? And you're like, what?
Yeah, still I acknowledge that I don't know everything, we don't know everything, and just that, just go with it. Nothing makes much sense at the moment, but
Yeah.
I still like the idea that there is a speed or a size in which our laws of physics break down and just do not apply anymore.
Well, I mean, at some point when you get small enough, you're no longer dealing with matter or energy. You are dealing with both at the same time.
Yeah.
You know,
What
it's
if
fucking weird, isn't it?
now here's the question. What if becoming, breaking the light barrier was possible? It's just that in the process, you break down into energy, and the trick in breaking the speed of light is to be able to come back from that state.
Well, I mean, you're not far off from the thought. I mean, it takes infinite energy to get to the speed of light. So you couldn't have mass. So you would have to be energy. I mean, you're not wrong, but how do you do that? And then how do you reconstruct yourself from...
I don't know. That's the trick.
it's a dodgy subject.
Once we figure that out, intergalactic travel becomes possible.
Gotta be like the dragon from Mega Man 2.
Or we just float space.
Or what you could do is just get warp drive working and then whatever.
Yeah,
I'd rather move at light speed. Or,
dude, why would you want to move at light speed? Why not move faster than light?
Actually, I tell you that I want to move at like C6
Why?
because
Warp speed could take you to like C fucking 20 gajillion.
I want to go fast.
You would
Because
be going fast.
Warp speed isn't going fast. It's just changing your locations quickly.
So?
It's
It
different.
would feel the same.
No, it
feel
wouldn't.
Dude, could you imagine going from here to Alpha Centauri in the blink of an eye? I mean, it wouldn't fucking matter how fast you moved. You'd be like, holy fuck, I want Alpha Centauri.
Yeah, but if I could do it while traveling that entire distance, it'd be even better.
You're not going to get a light speed jetpack, Hoovy. It's not going to happen.
I know. I can dream though.
You
And,
can.
and what's this you mean about jetpack? I want a robo-suit. I want a
There
mech
are some
travels at
people
light
that
speed.
would laugh at you, though. Just so you know.
What, if I had a robo-suit?
Yeah.
Alright, well, suck my mini nuke launcher. Laugh at this.
Emphasis on mini.
Ba-da-ba-ba-da.
It's a nuke launcher. You don't need a big one to kill one person. I'm gonna Gatling gun these things. That's how nukes work, right?
Technically, by any definition of velocity, warp speed breaks light speed. Yes, warp speed breaks light speed, but you don't break light speed.
What? No. If you're traveling at warp speed, you have to break light speed.
Say that again, Hoovy. That's fucking annoying voice acting in this game.
Therefore, if you're traveling at warp speed, you have to break light speed.
No.
Yes, by definition.
You don't. By definition, you have not broken light speed. Your warp bubble has broken light speed.
But I'm in the warp bubble.
Yes.
Therefore, I've broken light speed.
Your relative velocity is 0. Are you moving 62,000 miles an hour right this second, Hoovy, or are you stationary in front of your computer arguing with me about dorky shit?
I am moving at 2,100 miles an hour in front of my computer arguing about dorky shit.
Relative to the Earth, you are not moving. So, relative to what inside your warp bubble are you moving against that's making you move at light speed?
I don't know. I can't hear you over Jer's drums.
Okay. Since relative to the Earth, Hoovy, you are not moving. So relative to what, when you are in your warp bubble, are you moving at the speed of light or faster than it?
The center of all existence.
There is no such thing.
We're all rotating around something.
What?
We're all rotating around something.
Yeah, but if you are in space, relative to what inside your warp bubble, because your warp bubble is moving at the speed of light or faster, relative to what inside that bubble are you moving faster than the speed of light?
Okay, fine, you win.
Yeah, damn right I win. I didn't study fucking special relativity for nothing, Hoovy.
When did you study this?
I studied quite a bit of relativity.
Huh. I studied numbers.
And numbers can help you program computers.
Numbers can help me program computers, but not much else.
My general base of knowledge helps me do nothing.
How does it help you do nothing?
My knowledge of special and general relativity, what does that help me accomplish exactly, besides arguing with you?
Go be a physicist.
I've always wanted to put together a 40 kilovolt electric antenna array and see if you can warp space that way. I always kind of had a feeling you could.
Kilovolt?
Yeah, you need you need something pretty high up there in the voltage.
That's a lot of voltage.
Yes.
40,000 volts of electricity. That would kill a man.
In an antenna array that whose specific purpose would be to be in a measuring device. I can't remember the name of the measuring device. The drums are. It's not gonna help. I don't know. What the fuck is it called? You have lasers and you split the laser and then you measure the two lasers.
I know what you're talking about. I can't think of it.
Yeah, I can't think of it. I don't fucking know. But you would measure one laser, then you'd put the other laser through a 40 kilovolt or higher antenna array, and at the center of that, I think you could actually bend space.
I'm just waiting for the day we do get warp drive, because I know that will actually happen eventually. Unlike my dream of light speed. Faster than light speed, probably. But I'm waiting for it to become warp drive, so then we can work on making it man-portable warp drive. Because that's how technology works.
Yes.
We make it, and then we make it smaller.
I agree.
Now the question is, will we see warp drive in our lifetime?
Yes, we will.
I believe so.
It may not be faster than light at first, but we'll see the beginning of it. We won't see the expansion of it and the creation of a vast space empire, but we'll see the beginnings of it in our lifetime.
Then they realize that by traveling through warp space that you actually decrease the aging process. You can unage yourself.
No, that doesn't work like that, Hoovy.
I know.
You physically would have to be traveling at the speed of light. We've gone over this.
That's also the other thing I'm waiting for, some sort of fountain of youth cure.
Hoovy, do I have to...
I doubt is ever going to happen.
Hoovy, you're a numbers man, Hoovy. Don't make me explain time dilation to you. That'll fuck with you.
Oh, bring it. Bring it.
Why? Why do we have to talk about time dilation?
You brought it up, so let's go.
Okay, so Hoovy, let me ask you this question. What do you think happens at the speed of light?
At the speed of light, you would break down into pure energy and cease to exist as a being.
Okay. Well, let's say that doesn't happen. Let's say you remain physically constant. since we can't actually go the speed of light.
Yeah, it's theory.
Let's just say we go the speed of light, and what do you think happens? What is the speed of light to you? What do you see around you?
You go completely blind because you can't see because light can't reach the thing and get back to your eyeballs.
All right. Well, we know the blue shift and the red shift. It's like it's like when a train whistle goes by. But at the speed of light, and here's where it's gonna fuck with you. Time completely stands still, and the universe is nothing, and you are everywhere. How does that sound?
Time stands still, you are nothing, and the universe is...
No, the universe becomes nothing. It becomes a thing that doesn't exist anymore, and you are everywhere.
Explain.
Because the size of light is such that at its speed, if you were to go at the speed of light, exactly the speed of light, not faster or slower, but exactly c, you know how the universe contracts and expands depending on how fast you're going? Movie?
Yep, sorry, I forgot the talk button.
Jared, I hate to ask, man. Can you lower the volume, dude? It's we're trying to like talk, but it's not working. Cool. So you know, the faster you go, the narrower your beam of light gets, and you can't see, outside that beam of light. Okay. So the faster and faster and faster and faster and faster you go, the more compressed physically you're going to get. And when you reach C, you stop moving. You don't move anymore. You are mathematically everywhere, and the universe doesn't exist.
Oh, you compress down to next to nothing. As you infinitely get closer to C, you compress down infinitely much, and then at C, you expand infinitely.
No, you become so small that the universe doesn't exist to you.
Oh, that's the theory. You compress down into 2 dimensions. Essentially,
you become a photon at that point.
Oh, is it a photon?
Yeah, you essentially become a photon at that point.
Oh, okay.
So from a photon's point of view, none of this exists.
Well, yeah, photons aren't sentient beings.
So do you know how that relates to time dilation?
Not particularly, no.
So the best way for us to explain time, other than as a physical dimension, because that's really hard to wrap your head around. Even though people say, "Oh yeah, time's just a 4th dimension," it's really hard to wrap your fucking head around in a mathematical type of sense. So instead, try to explain time as the movement of light. So light is consistent for all observers at all speeds. Which means the faster you move, the more out of sync light is going to get with other light. Or light that's in your whatever speed bubble thing you are. Eventually what's going to happen is that you're just going to stop moving. Light's going to look like it stopped moving. Everything's going to look like it stopped moving. So time dilation occurs because light doesn't like you going that fast. Essentially. The best thing about it is you can calculate the fuck out of it, too. You can accurately predict how much time dilation occurs for satellites, planes, people in trains. It's pretty nifty stuff.
It actually works.
Well, there goes my theory that as we get infinitely fast, our laws of physics stop working.
Well, they do stop working. Although, unfortunately, as you're traveling as a photon, you still, from another observer, you still observe the laws of the universe. Photons still travel along the curvature of the universe, gravity and things like that, and black holes. So,
hence why light can't skip a black hole.
Well, yeah, but if you were the photon, you'd be fucked. You wouldn't know it, but you'd be fucked.
It is pretty interesting if you were to try and do light speed travel or close to light speed travel. How slow time would move for that person that's traveling that speed?
Nope, time would move exactly the same for them.
Yeah, but to the observer.
Oh yeah, they would slow the fuck down, but wouldn't also be visible either for the most part.
Yeah, but it's just like how far you can travel then.
Travel pretty fucking far. I'd rather travel in a warp bubble and still have my clocks in sync with everyone else.
Yeah, but I mean,
Although I guess my clocks might move a little bit faster since I'm not moving at 62,000 miles an hour. I'd die sooner as somebody who travels in a warp engine. How's that for a fucking drawback for being on Star Trek? You're on this warp engine device, you're moving at 0 miles an hour. It means the people on Earth are aging aging slower than you are.
Wow. Huh.
Didn't think about that, did you?
So wait, so why does the warp engine make you age faster? I think I missed something.
The faster you move, the slower you're going to age because of the relative time dilation of the
Okay.
speed of people, of the things, and the... God damn. I can't think. I can't talk. It's not working. Thank you, Mr. Wheeler.
What? I think someone's having a little bit of time compression of his own.
I'll be back. Gotta get some water. Sorry.
Every time I hear, "Oh, evolution's just a theory," well, so is general relativity, but we've proven that. We had to
Gravity's
prove
also a
that.
theory,
Otherwise,
but pretty sure if you jump off a cliff, you're gonna fall to the ground and splatter and die.
we had to
Where
prove
the fuck
general
am I
relativity.
running out of fuel? Who
We had
the
to
fuck
prove-
doesn't give a person enough fuel for a job?
We had to prove relativity, otherwise GPS wouldn't work.
Truckers?
Fuck this company in the fucking truck. We'll put it through a wall.
Time is just a ratio. I'm sorry, C is just a ratio. We're all traveling C. It's just to what ratio of speed and time are we traveling? There.
But what is time?
Or
It's-
dimensionality? Fuck you out of my way, boss. I got places to be, shit to do, people to kill. I mean, deliveries make.
Time is like a waterfall, so it doesn't exist.
It's like asking,
You
what is
fucking dick in your
hydrogen?
blue Volvo.
It's hydrogen?
Rude. You do physics by smashing animals on a head and assorted animals and fruits with hammers. That's fucking rude. My science is less science, alright?
The fuck do they think you are, Gallagher?
It makes sense.
Don,
That's-
you've heard my explanation of the double slit experiment, right?
Yeah.
I still don't fucking understand it.
It
How the
makes
fuck do you
perfect
not
sense.
understand it? Alright.
Because you're hitting monkeys with wrenches or hammers or whatever.
Well, think about how do I explain this? Do you want me to take you through you step by step?
Give me the cliff notes.
Let's do it step by step so you understand it. All right. Double slit experiment. You shoot one beam through a hole and through two slits, beam of light, and you expect to see two beams of light. Right? You don't. What you see is a wave pattern, an interference pattern. If you shoot photons one at a time through those two slits, you'd expect to see two slits of light. But you don't see that, even though you're shooting those small particle, a photon, one photon at a time through those beams. The photons are interfering with themselves. It makes an interference pattern. All right. Well, in order to figure out where those photons are going, you try to measure it. So instead, you measure it, and by the act of measuring, you no longer get an interference pattern. You get two beams of light instead. Why is this happening? Well, what does it mean to measure a photon? Do you know what it means? Okay. So how do you measure a photon? You don't do it with your eyes because you can't see photons. Your eye only interprets basically what is a heat map of what's in front of you to a very precise degree. So in order to measure a photon, what you can do is you can see its shadow. So you do that by hitting the photon with an electron and measuring the shadow. This limits you quite significantly because a photon is a 3D thing. Shadows, so there is a loss of information called Heisenberg uncertainty principle, but we won't go there. So this does what's called collapsing the quantum. I'm sorry, this is called the collapsing the not the wave state, called probability state. No, shit, what is it called? Give me some help here, guys. Well, I guess you could say collapsing the waveform. That's what I'm going for, I guess. and this collapses the wave function. That's what I'm looking for, and it forces the photon into basically taking a direct path and making a decision, essentially. So when you think about it, measuring is not some sort of mystical sort of thing where the act of observing is just passively looking at something changed how the photon reacted. Think it's some sort of quantum mechanical god shit going on. Instead, it's literally we have impacted the photon to take a measurement of it to see what the hell it's doing. Measurement is a destructive measurement. It's not a passive measurement. You can't passively measure something like that. Same vein, it's kind of like a monkey sitting in a field. You have a photon, the monkey, sitting in the field. You know the monkey's going to do something. You don't know what the monkey's going to do. So instead of letting the monkey choose what to do, which would result in an interference pattern in the wave of probabilities, you decide to force the monkey to do something. You smack it on the head. Therefore, once you smack the monkey in the head, you know something's going to happen. So we measure photons a lot. We smack monkeys in the heads with hammers.
So the slit is a vagina. That's what I'm understanding from this.
I still love that.
No, the slit.
Physics teachers are using this as their explanation now too.
There are physics teachers who have adopted this explanation of the double slit experiment, which is funny.
Just because it's a quick and easy to grasp concept.
I'm just imagining Lord Cat driving like a lunatic like this while explaining, giving a physics lecture, and it's just hilarious.
Giving a physics lesson over the CB radio.
Driving like a lunatic in the rain.
I have got to get the fuse changed to my CB radio and bring it on the stream.
I am so glad that after I heard that, I told that to the physics professor here at the local college. I'm so glad I told him that. And linked him to that video.
Did he immediately laugh at you?
Oh, he laughed at me. He thought it was cute, but then he sat down and thought about it.
Huh.
And went,
no.
Hold on.
There's some merit to this.
And he used it in his intro to advanced physics courses.
I mean, when you think about it, it's all you're doing is smacking a fucking monkey with a hammer. I mean, it forces, because the fundamental nature of the universe is statistics. It's statistical probabilities. That's the one law we've taken away from quantum mechanics, is that the universe is a very statistical, fundamentally type of beast. And if you force it to make a decision, it'll make a decision. It's just, it's a lot like, hitting a monkey with a hammer. I mean...
Sometimes the only way to see what a monkey's going to do is to hit it with a hammer. Unfortunately, this restricts the number of possibilities that the monkey's going to have. Generally going to be, we're going to strike, the monkey's going to attack.
It restricts it down to either the monkey's going to cower in fear or rip your face off.
But it's going to do something.
Or if it's masochistic, it may start jerking itself off.
Can you explain the Schrodinger's cat experiment?
It was a simple thought experiment. There was really no cat.
Isn't that just the prisoner dilemma?
No, it's not just prisoner dilemma.
Schrodinger's cat was just a rhetorical thought experiment where you have a cat in a box, and the cat was it a button, or was it just
alive
a function
or
of time?
dead?
No. It has more to do with that, and more than that. It's not just is a cat alive or dead? So here's how Schrodinger explains it. A cat is pinned up in a steel chamber along with following device, which must be secured against direct interference by the cat. In a Geiger counter, there is a tiny bit of radioactive substance so small that perhaps in the course of an hour the atom decays, but also with equal probability, perhaps none. If it happens, the counter tube discharges and through a relay releases a hammer that shatters a small flask of hydrocyanic acid. If one has left this entire system to itself for an hour, one would say that the cat still lives if meanwhile no atom has decayed. The psi function of the entire system would express this by having it in the living and the dead mixed out in equal parts. So the problem with the thought experiment is, when does a quantum system stop existing as a superposition of states and becomes one or the other? That's really what it's trying to get at. And you don't know until you look. The problem is, and this is the paradox, that you break down the potential of quantum superposition if you take that measurement, and it hasn't happened. And thus paradox of quantum mechanics and the craziness of it. So essentially, the cat in the box experiment. Is it alive or dead? You don't know until you open a box. That's all it is.
You don't know until you look at it.
But but in quantum mechanics, that has severe repercussions because if you take a measurement, you are destroying its quantum state. You are destroying the statistic nature of its state. You now know the specifics of it, and so it is no longer a probability. It doesn't prove quantum mechanics false. In fact, there's a lot of evidence that says it's right. But it's an interesting thought experiment to, I guess, kind of grasp the concept of what's going on at the quantum scale. I didn't quite make that turn as well as I had hoped I would.
That's okay. Insurance covers any damage.
Besides, you're still on the road.
Well, yeah, there was that. They didn't pull the equations out of their asses. Fucking Einstein built some of the equations. Just don't think they really understood what they were saying, like quantum teleportation. Einstein calls it spooks and at a distance. I look at it differently. I kind of look at it like a bowling ball on a sawmill. You know, you got this bowling ball and it's spinning, right? And then it's like in a box, all right? It's a bowling ball, and you can't see the bowling ball, but it's spinning. You know it's spinning. You just don't know which way it's spinning. And you cut the bowling ball in half, and you take this box with the bowling ball still spinning in it, and the cutting action has caused the bowling ball to spin in different directions. One in the original spin, one the counter spin, the opposite spin. You send the box to two different areas. Let's say one in Australia, one in New York, and then a scientist opens the box. And he gets up. He gets the bowling ball spinning upwards. Well, then he knows, thanks to quantum teleportation, intrinsically that the other electron, the bowling ball, is spinning down, and that's teleportation. It can't be done faster than light because it is kind of a little phenomenon. So just spin a bowling ball in half, send it to someone else. So here's half a bowling ball, and they'll look at you and like, what the fuck?
You know, this is why I'm glad I don't get into that quantum stuff.
It's all probabilities. All probabilities. That's quantum mechanics. And there's really complicated shit like quantum gravity. How the fuck does gravity affect things that small? And then how do you tie that into the larger theories of gravity? How does that make any sense? That's confusing. And how does that tie in with time? Very fundamental things with the universe we are mucking with.
Let's figure out gravity first, and then we'll work on time.
Yeah, but the problem is you can't just figure out gravity without understanding intrinsic other forms of time.
Okay,
it's a catch-22.
Let's wait until we get to the point where we're completely blocked up by time. Then we'll work on time until we can understand gravity better.
No, you can't do that because space-time is intrinsically linked together. It's like C is not C. It's not the speed of light. It's the speed of everything. It's the ratio it travel through time and space. So light doesn't travel through time at all. It has null time. That's the maximum theoretical speed you could ever achieve, which is through natural whatever processes and non-manipulation of space, ether, and whatever the fuck else manipulate. So that's the problem. Gravity is a bend in space-time. So you have to wait for that, and then those ratios fuck up, and then quantum gravity is confusing. And oh god, I tried reading about it, and my head decided to start bleeding. I started bleeding out of my eyes because the paradoxes and the inherent incompatibilities between quantum gravity and Einstein. Einstein's theory of relativity is amazing and astounding, and nobody knows how to fix it, and it's a slow, arduous process. Yeah, photons don't experience time. Photons don't experience the universe either. They experience no time or distance. But you can't really talk about it in that sense because there is no valid frame of reference exists at C. Speed C, time null. It doesn't exist. How does time null exist?
And this is, of course, just the matter that can't go faster than constant, because
no one said matter can't go faster than C. No one said matter couldn't go faster than C, so we've never observed anything like that. It's just you can't go at C.
Well, we don't think we can at this point, but
anything
we think
with
space
mass
can go faster than...
Yeah.
Nothing with mass can go the speed of light.
That's true. Have to be massless. If you have mass, you experience time.
And here I gave up trying to figure out physics with the very basics of electromagnetism.
Really? That shit's actually kind of elementary compared to the shit we're talking about.
I know, and that's why my mind is just completely blown.
I still remember the night we all kind of went, wait, what? When they figured out that there's a negative Kelvin scale.
That's a mathematical trick. I mean, it's technically negative Kelvin, but it's more of a mathematical trick that they discovered, which was pretty cool. Still, it's all
the thing about it is
it's not
Kelvin,
the traditional negative Kelvin. It's not like it's colder than absolute zero.
It only measures energy, and 0 Kelvin is technically no energy, not no temperature.
Yeah, which is it's still a thing, nevertheless. It's a nice little trick. Might be interesting. Might be useful. We don't know.
So I did dumb.
So you know those headphone and microphone combos?
Yeah, the headsets?
Yeah. The microphone stabbed me in the eye.
Oh dear, did you lose the eye?
No, thankfully.
Okay.
But it hurt like a son of a bitch.
Yeah.
Did it kill you?
Probably bruised the eye.
Do you have a cool eye patch now?
No.
Aww.
Are you patches?
Here we are talking about C being a ratio between speed and time, and here comes Cold Guy. Hey guys, I poked myself in the eye with the microphone.
Way to bring us all back down to earth.
And bring us back on the reality that we have no idea what we're talking about.
Thank you.
Thank you, Patrick.